All right, who's ready for J25? In this section, we're going to go over simplifying radical expressions and several different things that we can do with radical expressions, okay? And so before we get started, I just want to make sure you know some of the verbiage that we're going to use, okay? This number right here is called our index number, okay? It's also referred to as our root, right? So if we're talking about a square root or a cube root, we're talking about that little 2 or that little 3 that's written here in the crease of our radical symbol, okay? This symbol, like I just said, is our radical symbol. And whatever happens to be under the radical symbol, we refer to as the radicand. Radicand, okay? So again, if we say something about our index is 4 and we have a polynomial radicand, I want to make sure that you understand that means that our little root number here is 4 and that we have a polynomial underneath, okay? So these are just a few words to kind of familiarize yourself with, okay? So a couple of things when we're dealing with radicals to be aware of. When we have the root and the exponent or the power being the same, then they cancel each other out, kind of like a square and a square root, right? If it's even, we use absolute value bars around our answer because we don't know if that a started off positive or negative, okay? It's kind of like when we say the square root of 25 could be plus or minus 5, right? We don't know if it started positive or negative, so we just put an absolute value around it. So we're saying whatever that number is, we know its absolute value is 5, right? If it's odd, we don't have to worry about the absolute value bars because if we're taking an odd root of a negative number, it's going to turn out negative. If we're taking an odd root of a positive number, it's going to turn out positive. So we don't have to worry about the either or combination, okay? When we have a radical that has several things underneath it, we can actually separate it into individual radicals that are being multiplied together. Or if we're multiplying two radicals, right, we can multiply them and write it as one radical as long as those index numbers match. Okay, so we'll look at why that will be helpful here in a little bit. The same thing is true when we're taking a radical expression that involves a fraction. We can look at it as the root of the entire fraction, or we can simplify it by just looking at the root of the top and the root of the bottom, okay? Obviously where the bottom's not 0, okay? And then the other one that we'll get into this a little bit more later is order of operation. We can kind of do an either or here. So notice we have something raised to a power under our radical. And what this fifth step says is that we can actually apply the power first and then take the radical, or we can take the radical first and then apply the power afterwards. So that's going to kind of help us out a little bit as well. Okay, so let's just kind of jump in and look at simplifying some of these radical expressions. Hopefully this is something maybe we would have seen before, but if not, hopefully it won't be the worst thing you've ever seen. So here we have a fifth root. Okay, so when we see this is our index number. This tells us how many copies of a number that we would need in order to bring that number outside the radical, okay? And we can think about this as the fifth root of 32 divided by the fifth root of 243. We can do those numbers individually, okay? Now I know some of your calculators are capable of doing this, but you're not going to be able to use graphing calculators on your exam, so I want to make sure you know how to simplify this by hand. Okay, if you're not sure what the fifth root of 32 is, or if it even is a perfect fifth root, I want to show you how to simplify. So if we take 32 and we prime factor it, okay, 32 is even, so I'm going to go ahead and say we know 2 goes into it, right? 2 goes into it 16 times. 16 is also even, so I can write 16 as 2 times 8, I can write 8 as 2 times 4, and then 4 is 2 times 2. Okay, so notice I have 1, 2, 3, 4, 5 copies of a 2. So 32 is actually 2 to the 5th power. So I can rewrite this as the 5th root of 2 to the 5th power, right? And then by this rule up here, we know that if I have the same root and the same exponent around my base, those cancel, right? So I already know the top of my fraction just becomes a 2, right? Now I want to look at the bottom. Oh, and then the other way, if we think about it in copies, this means I need 5 copies of a number to bring that number out. So if we look here, we have 1, 2, 3, 4, 5 2s. So it's kind of like saying if I have 5 copies of a 2, then I can bring that 2 outside of the radical. And since I took out those 5 2s, notice I didn't have any other factors left over. So I bring the 2 out, and there's nothing left over underneath a radical. Okay, let's look at the same thing with 243. If I want to prime factor 243, it's not even, so 2 doesn't go into it. So then I want to try 3. To see if 3 goes into a number, you can just add all the digits together. So 2 plus 4 is 6, plus 3 is 9, and if 3 goes into that sum, then you know 3 goes into that number. So 3 should go into this number. So 3 goes into 243, what, 81 times, right? 3 also goes into 81, 27 times, right? 27 is divisible by 3 9 times, and then 9 is 3 times 3 as well. So we ended up with 1, 2, 3, 4, 5 copies of a 3. So this is 3 to the 5th. So I can rewrite the 5th root of 243 as the 5th root of 3 to the 5th, and then the 5th power and the 5th root cancel, right? So this just becomes 2/3. Okay, or if you think of it in terms of copies, again, it takes 5 copies in this case to bring out a number, and I had 5 copies of a 3, which means I can bring a 3 out. Okay, let's look at another one that doesn't end up as like a perfect. This was a perfect 5th root because it simplified down to just a nice number with nothing left over under the radical. Let's look at one that doesn't end up being a nice number. So 216, that's an even number, so I'm going to go ahead and just start factoring it. So I have 2 goes into it, what, 108 times? 108 is also even, so that's going to go in 2 times, what, 54? And then 54 is, well, 9 times 6 is what comes to mind for me. And then I'm going to break down each of these. 9 is 3 times 3, and 6 is 2 times 3. Okay, so these are the numbers that I have as being my prime factored numbers. And notice my little number here, if there's nothing written there. The way we read this is a square root. So that means my index number is an implied 2, right? So that means I need 2 copies of a number in order to bring that number out. So if I look at my prime factoring here, I have 2 2s. So this tells me I can bring out a 2. Right? I also have 2 copies of a 3, so I can bring out a 3, right? And then notice this 2 and this 3, I don't have 2 copies of. So those are going to stay under the radical. So I'm going to go ahead and just write over here what I've done. I've brought out a 2, and I've also brought out a 3, so I'm going to be multiplying those together. And then underneath my square root, I also have a 2 and a 3 left over, right? And now I want to look at my x's and my y's. I have 5 x's, right? So if I think about 5 x's, 1, 2, 3, 4, 5, what this is telling me is I can bring 1 x out for every 2 copies that I have. So here's 2 copies of an x, so I can bring an x out. Here's 2 copies of an x, so I can bring an x out. So I'm bringing out an x times an x, right? And then notice I have 1 extra copy left over. So I'm going to leave that in there. Another way of figuring out variables so that you don't have to write them all out is you can think of just taking the power, the number of x's you have, and dividing it by your index. So here we have x to the 5th, and we have a square root. So how many times does 2 goes into 5? Well, 2 goes into 5 2 times, right? So we brought out 2 x's with 1 remainder, okay? Same thing with y to the 3rd. If I have 3 y's, y times y, and I need 2 copies to bring out a y, I can bring out 1 y, right? Because I have two y's here, which tells me I can bring out a y. And then notice I'm left with one copy of a y underneath. And then once I've got it all figured out, then I just kind of simplify the way that I write it. So I'm going to multiply my numbers together, which gives me 6. X times x is x squared. I have a y. And then under my square root, I'm left with 6xy. Okay. Maybe something we've seen before. Possibly. Let's look at a few more things we can do with radicals. Okay. On this one, I have a square root of a polynomial, right? This is being added and subtracted. And if you look back at our notes here, we don't have any rules for addition or subtraction under a radical. The only thing we have rules for is multiplication, right? Or multiple copies of the same base. So I can't simplify this as it's written with just terms being added and subtracted. So my only hope is that hopefully this is something that I can factor. So I'm going to go ahead and see if I can factor it. I have no greatest common factor, right? Because this doesn't have any numbers or variables in common. So I'm going to go ahead and go straight to my sum product chart. My sum is my middle coefficient, which in this case is -4. And my product is my first coefficient, which is 1, times my last coefficient, 4. So I need something that multiplies to give me +4 that can combine to give me -4, which would have to be -2 and -2, right? Or -2 minus 2. And then because our leading coefficient is a 1, that tells me that I can use the shortcut. Yay, right? So the shortcut says the numbers in my chart are going to be the numbers in my factored quantities. So this is going to factor into the quantity x minus 2 times x minus 2. So I can rewrite this whole thing as the square root of x minus 2 times x minus 2. Or what helps us a little bit more is to be able to write this as the square root of x minus 2 squared, right? Because if I have 2 copies of that quantity, I can write it as a squared. And then when there's no index number written here, it's an implied square root, right? Or an implied 2. So if I take the square root of something squared, I'm left with what's underneath it, right? So I get x minus 2. Okay. All right. Let's look at our next one. On the next one, and actually because this is a square, I'm not sure in my math lab, you'll have to check. They may leave it as the absolute value of x minus 2 since it was a square and we're not sure what x is. I'll have to look on that, okay? So just be aware they may have you enter it with absolute values if it's an even index, okay? All right, let's look at this next one. This next one is combining radical expressions, okay? And the only way that we can combine radical expressions is if we have like terms. So remember, just review here. Review like terms. So like terms, if I had something like x squared minus 2x plus 4x minus 1, right? Like terms have the same variables raised to the same powers. So here my like terms would be my x terms, right? And when I combine them, I just combine the number parts, right? When I combine the number parts, this would give me 2x. Notice the label doesn't change, right? But I can combine the number parts of the terms that have the same label. Okay, the same thing is true with radical expressions. If I had something like 7 square root of 3 minus 4 square root of 5 plus 2 square root of 3, okay, the only ones that I can combine are the ones that have the same label, meaning the same radical with the same radicand, right? So they have to both be square roots or whatever root you're dealing with, and they both have to have the same radicand or the same thing under the radical in order to be considered like terms, okay? So in this case, I would just combine those number parts, which would then give me 9 square root of 3, right? Minus 4 square root of 5. And that would be as far as I can go because these are now not like terms, okay? So this was just a little review. So let's look at ours. So the way it's written right now, these are not like terms. I can't combine the 3 and the 8 because the radicals don't match. Excuse me. So we want to start off by simplifying the radicals as much as we can to then see if we can come up with something that has like terms. So I'm going to start by simplifying the square root of 50. I'm going to see if I can focus this a little bit more. There, that's better. That's better. All right, so I'm going to go ahead and prime factor 50. 50 is the same thing as 2 times 25, and 25 is a perfect square, right? This is 5 times 5. And notice here, my little index number, if there's nothing written there, is a 2, which means I need 2 copies of a number in order to be able to bring that number out. So here I have 2 copies of a 5. So I can bring out a 5, but there's still going to be a 2 left over, okay? So I had an 8 that was out front already. So I have the 8 that was out front already times the 5 that I'm bringing out, and then underneath my square root, I'm now just going to be left with that leftover factor of 2, okay? Then I want to do the same thing with the next term. The next term, I have a minus 3, right, that's already out there. And then let's see what we can do with 8. 8 is 2 times 4. 4 is 2 times 2. Again, I'm looking for 2 copies because this is a square root. So I have 2 copies of a 2, which means I can bring out a 2. Okay, so I have the 3 that was already out there, right, from my original, and then this 2 that I'm bringing out. So I multiply the 2 that I'm bringing out, and then underneath my radical, notice I'm just left with that last factor of 2. So I go ahead and simplify my new expression. So this means I have 40 square root of 2 minus 6 square root of 2, and now they are like terms. Okay, so now that they are written as like terms, I can go ahead and combine them. So 40 minus 6 leaves me with 34 square root of 2. And I just leave it like that, okay? All right, and then the other one I want to show you is multiplying radical expressions. So when we multiply, we can only multiply numbers that are outside the radical with numbers outside the radical. We can only multiply numbers inside the radical with numbers inside the radical, okay? And we can only multiply radicals with radicals if they have the same index. So notice here, both of these are square roots, so that's okay. We can go ahead and work with this, okay? All right, so let's go ahead and start distributing. So we have 5 times 4, which gives me 20, right? And then I have 5 times 3 square root of 2. So 5 and 3 I can multiply together because those are both outside the radical. So 5 times 3 is 15. And then I just tack on the square root of 2. Okay. Same thing with this next one. When I distribute negative square root of 2 times 4, I can only multiply that 4 with outside values. So you can think of this as like a negative 1 in front of that. So 4 times negative 1, or 4 times a negative, right, makes it a negative 4 square root of 2. And then I'm going to distribute that negative square root of 2 times 3 square root of 2. So again, I multiply outside numbers with outside numbers. So negative 1 times 3 gives me negative 3. And then square root of 2 times square root of 2 gives me square root of 4. Okay, and now I can do some simplifying. I have like terms here, right? So I have 20 plus 11 square root of 2. When I combine those, I combine the number parts. The label stays the same. And then here, I have negative 3 times the square root of 4, right? Well, the square root of 4 is just 2, right? So really, this just becomes negative 6. So I have 20 plus 11 times the square root of 2 minus 6. And now I can combine my 20 and my negative 6, which gives me 14 plus 11 square root of 2. Okay, and I can't combine any further because the 11 has a square root and the 14 doesn't. So these are not like terms. Okay. All right. So on the next page, there are six for you guys to try. So go ahead and pause the video and give it a try. And once you're done or you're ready to be checked, unpause the video and we'll go over it and see how you did. Let's look at number 1. All right, so some of you may have been able to do this one in your head. That's totally fine. Others may have needed to break it down. That's okay too. So we have a square root, which means we need 2 copies of a number in order to bring a number out. And notice if we factor 9, that becomes 3 times 3. So I have exactly 2 copies of a 3. So I can bring a 3 out. And notice I don't have any more copies of a number at all left over. That was the entire number. So 3 comes out, no numbers left under the radical. Same thing with w squared. W squared means I have w times w. That's exactly 2 copies of that number. So I can bring out the w, and there's no leftovers. There's nothing left under the radical. So I brought out a 3, I brought out a w, I have nothing left. So that means it simplifies just to 3w. Okay. On number 2, now we're dealing with a 4th root. So a 4th root says that I need 4 copies of a number in order to bring a number out. So I'm going to go ahead and factor 81. I know 81 is 9 times 9, and each of the 9s are 3 times 3. Excuse me. So that means that I ended up with 4 copies of a 3 exactly, right? So 4 copies of a 3 means I can bring out 1 3. And notice I don't have any copies of any other number left over. So there's going to be no numbers left under my radical. So just the 3 that came out, and then the x to the 8th. So x to the 8th means I have 8 copies of an x. So you can think about writing out 8 copies of an x, and for every 4 copies you can bring out 1 x, which means that you should be able to bring out 2 x's. Or you can think about dividing it. If you need 4 copies and you have 8, you can think how many times does 4 go into 8? Well, 4 goes into 8 evenly 2 times. So that means you can bring out 2 copies of an x. And notice we don't have any x's left over because it evenly came out with 2 copies, right? So that means we're bringing out a 3, we're bringing out an x, we're bringing out another x, which means we're bringing out a 3x squared, okay? All right, let's look at another one. When I look at number 3, if I were to try to simplify these radicals individually, right? 15 is 3 times 5. 35 is 5 times 7, and I don't have 2 copies of anything under each individual radical, right? Because this is a square root, so I need at least 2 copies to bring a number out. So instead of doing them individually, what I'm going to do is I'm going to use that property that says if we have 2 radicals being multiplied together that have the same index, we can go ahead and multiply what's underneath them. Meaning instead of square root of 15 times square root of 35, we could do square root of 15 times 35. And I don't even care what that huge number equals because I already know that 15 is 3 times 5, and I know that 35 is 5 times 7. So I went ahead and just took all their factors and wrote them here. Because if I were to multiply all that together, it would tell me what 15 times 35 is. But I don't care about that because I'm trying to simplify it, right? So now that I have it all under one radical, again, it's still a square root. So 2 copies will bring a number out, and I can see that I have 2 copies of a 5. So I can bring out my 5, and notice I have a 3 and a 7 that's left over. So I just multiply the 3 and the 7, which means I'm left with a 21 under my radical, okay? All right, let's look at another one. Same idea, just like that, but this time with also having variables. So on number 4, if I multiply my numbers together, 2 times 12, that gives me 24. X cubed times x gives me x to the 4th. And y times y gives me y, gives me y squared. Let me write that down. That's going to change my answer. Gives me a y squared, right? All right, so when I go to simplify 24, 24 is 4 times 6. 4 breaks down to 2 times 2, and 6 breaks down to 2 times 3. My index number here is a 2, right? So if I'm dealing with a square root, that means I need 2 copies of a number to bring that number out. So I have 2 copies of a 2, so I can bring out a 2, and notice I'm left with a 2 and a 3 underneath my square root. So here's the 2 that I brought out, and the 2 times 3 that's stuck in there leaves me with a 6, right? All right, and then I look at my variables. I have 4 x's. So again, you can say how many times does 2 go into 4? It goes in evenly 2 times. So that means I can bring out an x squared with no x's left over. Or you can take those 4 x's and write out 4 copies of an x, right? And for each 2, you can pull out an x. So I have 2 equal copies, right? So I can bring out 2 x's, which means I'm bringing out an x squared. And then this is not correct. I don't know how to get rid of that. Where's my little, here we go. This one's not correct because this was not just a y, this was a y squared. So y squared means I have 2 copies of a y, right? And because this is a square root, that means for every 2 copies, I can bring out 1 y. So since I have 2 copies here, I can bring out a y. So I should have a y here and no y's left over underneath my radical, right? Or again, the shortcut is how many times does 2 go into 2? 2 goes into 2 one time evenly with no leftovers. So if it goes in one time evenly, I can bring out 1 y. No remainder, no leftovers means no y's left underneath the radical. Okay? All right, let's look at number 5. Number 5, we're trying to combine radical expressions, but right now they are not like terms. So if they're not like terms, we have to break down the numbers underneath the radical to see if we can then combine them, right? So 32, if we break it down, is 2 times 16, 2 times 8, 2 times 4, and 2 times 2, right? Or you might remember from the examples I did that this is 2 to the 5th power, right? So for every 2 copies of a 2, I can bring a 2 out. So here's 2 copies, so I'm bringing out that 2. Here's 2 more copies, I'm bringing out that 2. And then I'm left with a factor of 2. So notice I already had a 2 in front of the radical, right? Then I brought out another, and then I brought out the first one, so there's that one. And then I brought out an additional one, so there's that one. And then underneath the radical, I'm left with that extra copy of 2. So when I multiply these together, this first term becomes 8 square root of 2. Okay? And then I want to do the same thing with the middle one. 8 is 2 times 4. 4 is 2 times 2. Again, it's a square root, so I need 2 copies of a number to bring that number out. So I have 2 copies of a 2 right here, so I bring that 2 out. And then I have 1 copy of a 2 left over. So again, there's a 3 already out front, so there's that 3. And then I'm bringing out a 2, so here's the 2. And then left underneath my radical is that extra factor of 2. So 3 times 2 makes this 6 square root of 2. Okay, for that second term. For the last term, when I simplify 18, 18 is 2 times 9. 9 is 3 times 3. So 2 copies of a 3 means I can bring that 3 out. And then I'm left with this extra factor of 2. Okay. So again, this one had a 4 out front. So there's my negative 4, right? And then I brought out the 3. So here's the 3 I brought out. And then I was left with a 2 extra factor. So that 2 stays underneath the radical. So negative 4 times 3 makes this a negative 12 square root of 2. And now all of these are like terms. So once they're all like terms, I can combine the number parts. So 8 and 6 gives me 14, minus 12 gives me 2 square root of 2. Okay? And then the very last one is multiplying. So when we distribute here, 2 times 5 gives me 10. 2 times 2 square root of 3, I can only multiply the 2's because they're outside numbers. So 2 times 2 gives me 4, and then I just put the square root of 3 on it. Okay. Same thing when I distribute the square root of 3. Square root of 3 times 5. 5 and 3 are not in the same spot. 5 is outside, 3 is under the radical. So we just write it as 5 square root of 3. And then I multiply the square root of 3 times 2 square root of 3. So 2 is on the outside with nothing to multiply it by. And then square root of 3 times square root of 3 gives me square root of 9. Okay. So then I do some simplifying. I can go ahead and combine these like terms, right? So 4 square root of 3 and 5 square root of 3 gives me 9 square root of 3, right? And then the square root of 9 on this last term just becomes a 3. So 2 times 3 is 6. And now I can combine my 10 and my 6, which gives me 16 plus 9 square root of 3. And I can't go any further because these are not like terms, right? This one has a radical, this one doesn't, so I stop there and I'm done. All right. Okay, so that is the end of J25, which is all about simplifying radical expressions. I know it was kind of a lot of different topics, but all related because we're all just simplifying radical expressions on each of them, okay? So if you have any issues or any questions about this homework, please let me know. Otherwise, I'll see you on the next section.